Hello, I'd like to demonstrate the object-image relationship for a convex mirror. Here I have a diagram of a convex mirror. This shows light rays coming up parallel to the axis and then diverging away as if coming from a virtual focal point located here. Here I have an actual object with light rays coming up from the top of the object and then diverging away as if coming from a virtual image located at this point. We notice in the case of the convex mirror that the image is smaller than the object. The image is closer to the mirror than is the object. The image is erect and it's virtual. So now I'd like to demonstrate this with an object here. I've got a light globe with an arrow drawn on it. That arrow will be our object. And we have this current turned up just a little bit on the light globe here so we get better contrast. And we'll face that arrow toward the mirror. Here's the convex mirror is on this side. And then what we want to do is have the camera come down and take a look in this direction at the light that reflects from the mirror into the camera so we can actually see that virtual image that's formed back behind the mirror as a result of the object being out in front of the mirror. So now we have the object here facing the mirror. I'll turn this object toward the camera so you can see the arrow there. This arrow will be our object. I'll face that toward the mirror, and then we'll take a look at the image in the mirror from this object. Notice that the image is smaller than the object, and if we move the mirror closer to the object, then the image comes up closer also and becomes larger. It's almost like a plane mirror when object and image are very close together there, right up near the surface of the mirror. As the mirror moves further back, the object moves further away from the mirror. Notice the image also moves further back while all the time remaining erect and virtual.